Hi, this is Mike of 71 Squared and welcome to tutorial 7 in our series on writing a game on the iPhone. This tutorial is only a quick one. It's really to cover off a blog post that I've done just recently about singleton methods or singleton classes. It's become pretty obvious as I've been going through the tutorial so far and in some of the work that I'm doing now for future tutorials that having a single place in which to manage the state of your game. So, in other words, somewhere that's going to hold what's the state of the game itself. Is it paused? Is it running? And so on. As well as being able to manage OpenGL state. What's the blend type that's being used? Maybe what's the currently bound texture? And so on. Managing them yourself is important. And it's something that is going to be useful to have a single location, a single place where that information is held, that all of the classes we're implementing can actually go and request it. So we have a number of classes that actually render to the screen. We've got the image class, we've got the animation class, the angle code class, sorry, not the animation class, that uses image. We've got the image class, the angle code font class, and the tile map class. They all render to the screen themselves, and so they all bind a texture, which means they all need to be able to understand if the currently bound texture is the same and therefore not bind again, saving some game loops, or sorry, saving some cycles and keeping the performance up as best we can. So I've had a number of ways of doing this. One was that I was using the app delegate as being that single source of information, which, to be honest, having again, it was brought up on the blogs and having read up on other websites, it's not best practice. It sort of really breaks the model view controller pattern because the app delegate isn't really designed in the MVC way to hold that information. It's much better for us to create our own object specifically designed to manage and store the state of our game and of our OpenGL settings. So I tried that. I've then currently got it set so that it actually queries OpenGL to go and find out what the state, what the currently bound texture is. Again, further reading has shown that not to be a good idea because it can have a significant performance hit. So that really sort of pushed me down the route of actually using a singleton class to do the work. So what I'll do is I'll jump straight into the creation of that singleton class so that we can actually see what I'm talking about, and it'll hopefully make a little bit more sense. So I'm going to bring up the project we've got. So I'm carrying on from tutorial 6 here, same project that we had before. So I'm going to start off by creating a new group called Common. And this is where I'm going to store the definition of my singleton class, and it's also where in future episodes or future tutorials I'm going to be storing other information or other common information that's useful for us. So for example, type definitions I'm going to pull together into one location. I'm also going to be using some inline functions which I use for the particle system, which again will all be in this one location. So for that reason I'm going to be having common here as my group folder in which I'm going to place those things. So inside common, we'll create a new object, which is going to be an NSObject class. And what I'm going to do is I'm going to call it singleton game state. Okay, so singleton is really just to remind us it's a singleton version. There's not going to be multiple instances of it. Game state, well, that's really what it's controlling. Okay, so that gives us our two folders, our .h and our .m. And inside .h, what we need to do is, first of all, I'm going to import the OpenGL side of things. So I'm going to say OpenGL es/es1/gl.h because there are constants, GL constants I'm going to want to use in here. So I'll import that so I can access them. I'm then going to create the one thing that at the moment I'm going to track. We'll obviously build this up over time and track many more things, but the currently bound texture is the most obvious one that I want to track at the moment. So I'm going to create the currently bound texture as a property, like so. And I'm going to say it's a GL unsigned integer, and I'm going to call it currently bound texture, like so, and that's it. So that's the only variable that I'm going to actually track. And what I'll do is I'll create a property entry for it, so that we can actually then define getters and setters automatically for it as necessary. So that's glue in currently bound texture. The next thing I'm going to do is I'm going to create a method definition in our header, but normally we would use the minus sign and do something like minus void and then have a method name like that. And the minus is telling the compiler that this is going to be a method, a per instance method. So every time we allocate and we do an allocation and an initialization, it creates a brand new instance of this class. And the minus is telling the compiler that we're going to have a version of this method inside every single instance, so a copy in every instance that we create. Now what we want to do is we want to create a single instance only for the entire game, and we want the other objects that are going to access it, the other classes like image and angle code and tile map, to all access the one instance of this particular class itself. And to do that, we need to provide a method that can actually provide those classes that single instance. So rather than them actually being responsible for allocating and initializing a new instance of this Singleton GameState class, we want to be able to call the Singleton GameState class and say, please pass me an instance, or please pass me the instance that I should be referencing to get my data. And that one instance will be used all of the time. So that means that we're going to actually specify this method with a plus, which means it's a class-based method, not an instance-based method. And what this method is going to be doing is passing back a copy of, or it's going to be passing back an instance of the Singleton GameState. And I'm actually going to call the method shared GameState instance. Now there are versions of this that Apple do, sorry, not of this particular class, but there are classes that, or objects that Apple have actually got that do something similar. So for example, the UI application class, that there's only one of those, and you can actually go and grab its shared instance or shared application. And so the word shared at the beginning is telling you actually that there's only one version of it, and you're just getting a copy of a pointer to that single instance that's been created. So that's why I've put shared at the beginning of the name of this method as well. That's all we need to do inside our header. That's the only definition required. So I'm going to save that. And what we'll do is we'll then move on and actually have a look at what we have to create inside the implementation. So I'll switch to the implementation file here. And the first thing I'm going to do is I'm going to synthesize the currently bound texture, so that will create our getter and setters. And I then need to create the implementation for the method that we have just defined. So that's going to become a Singleton GameState is the return object, and remember we called it shared GameState instance was the actual name of the method that we're going to have, and squiggly brackets. Now what we want is we want a single copy of this to be used everywhere. So I'm going to create a static variable here, and it's going to be of type Singleton GameState, and it's going to be called shared GameState instance. So the static keyword is basically saying that for this class there's only ever going to be one version of this Singleton GameState, because we only want, once shared GameState instance has been instantiated, we only ever want to be able to grab that one instance. We don't want to have multiple copies of that created. So by defining it as static, we're saying we want there to only be one of those created inside this method. So no matter how many times this method gets called inside this class, it's only ever going to use one static instance of that particular variable. The next one is a new keyword that we've not used before, which is actually synchronized. And what synchronized does is basically exactly the same as Java if you know Java, and it actually puts a lock on that particular object. So synchronized self puts a lock on this particular class for this particular thread. So that if two threads tried to run this method at the same time, the first thread that got here would place a lock on that object at that point, and then that lock will be held until whatever is in these squiggly brackets is actually completed before the next thread does. Before the lock is released and the next thread can gain access to it. We're not using threads in our game, but it's just good practice, I think, to have that in there, and it doesn't take up any time at all. So once we've actually synchronized and we've taken out that lock, we're then going to say if not shared game state instance. So in other words, if it's currently empty, it's not been instantiated yet, then we want to create an instance of it. It means it's the first time this particular class method has been called. And the first time it's called inside our game, we do want to create a instance or an instance of this particular class object. So that's what we're doing there. Very straightforward, as we do when we normally allocate an allocate and initialize an object. We've just done that. So shared game state instance now is a representation of a new instance of our singleton game state class. So I can close the if, I can close the synchronized, and basically what we do is we return that particular shared instance and we close that method. So if we just run through that, the first time we call this particular method is going to be when we initialize our game. So we're going to call this shared game state instance method, and it's going to create our singleton, our static singleton game state variable called shared game state instance. It's then going to take a lockout on the object while it checks to see if that particular variable has been instantiated or not. Because it's in the initialize loop of our game, it won't have been, it's going to be empty, so we actually go and create, we allocate and do what is necessary to create a new instance of that particular object. And if we wanted to, we could have other methods inside this class which actually do things when we initialize. At the moment, we're literally using it as a holder for our currently bound texture, so we don't really need to do anything else at the moment, but you could if you wanted to. So we create and allocate a new instance, and we then return that instance to whatever called it, which is going to be our initialization method inside our game. The next time we want to grab the shared instance could be inside, for example, the image class, and when it calls, it's going to go through the same method, it's going to look at the same shared variable called shared game state instance, and this time when it says, is there an instance of it, it will say, well, there is, because the previous time we went through, we created an instance of that. So it won't create a new instance, it will just return the instance that already exists. So there you can see that's how we're doing the sharing. We've created that single instance of this class, which every time now we go and try and grab that shared instance using the shared game instance method, we will just be returned that version or that single instance of that particular object, that particular class that we've created. And that allows us to share whatever information is inside here with all the classes that call the shared game state instance. And it means that we can implement game specific code in here. So for example, we may not have just a very basic getter and setter that the compiler creates using synthesize. We may want to create our own methods in here that again are game wide. They are to do with state, and we want to use them no matter where we are in the game, and they're going to be useful. So we're keeping with that whole model view controller pattern in that app delegate is all around setting up the application and getting the application running regardless of what kind of application it is. When we're actually in the EAGL view side, that's to do with actually rendering the screen and controlling the user input, not really around state. So to keep state separate, we're creating this new specific object of which there's only going to be one instance. Now there are ways of stopping people from actually being able to instantiate more than one instance, because if I wanted to, I could do an alloc init externally from Singleton. So rather than using that shared game state instance, I could just do an alloc init as I would for a normal object, and it would create multiple instances of that. But because it's our game, we're not sharing the code with anybody. We know this is a Singleton instance, and so I'm not going to implement that code at the moment. But that's basically this almost complete. The only thing we need to add here is the void on it for dealloc. So we want to have a dealloc routine in here as well. And we just want to do super dealloc for the moment. Like that, when we get rid of this particular class. So I've just built and saved that to make sure I've not introduced any obvious errors, and that's built okay. So now we can actually have a go at putting this into the game and seeing where it needs to be placed. So we do that by going to our EAGL view implementation. And what we'll do first is we'll actually go to the header, and I will first off import the header for our Singleton class like that, and I will then at the top, let's have a look. No, in fact, I'll just drop it in at the bottom. So after the screen bounds, I'll drop in here, and it'll be called game state. And this is going to be a Singleton game state instance, and I'm going to call it shared game state, like so. And that's what we're going to load our copy of this instance into, so we can actually access the variables. I don't have to do that. I could just keep calling the Singleton and saying, give me back your shared instance, and at the same time grab the parameters, the properties, but I prefer doing it this way, so I can actually just do that once and then just use it as many times as I want, and it does save on a tiny bit of overhead as well. So I'll save that, and we'll move to the implementation. And what I need to do inside here is where we actually initialize our initialize our game, which is just here, I'm going to go and grab our game state. So I'm going to say our shared game state variable equals. Now you'll notice that I'm not using an instance name. I haven't allocated or initialized this class. I'm calling the class directly, and I'm calling the shared game state instance method in that class, which is a class method, not an instance method, remember? And that's because it had a plus, not a minus in front of it. And from what we've just described, what's going to happen is that is going to return into the shared game state variable the instance that is now being created. Because this is the first time we've called that method, it's going to actually do an alloc and an init on that Singleton game state object and pass that instance back to us, so we can then reference and access it. We don't need to do anything else inside EAGL view because we're not using that state variable within here, but we are going to use it inside the image class, for example, so that's what we'll change next. So I'll save my EAGL view, and we'll jump to the image.h file, and again we'll do an import of the Singleton object, and at the top here we'll add our game state variable just like we did in the previous EAGL view class, and I'm going to call it the same, shared game state. Save that. So that's what we're going to be loading our instance into. I'm going to drop into the implementation now, and I'm going to, inside my init implementation routine here, which always gets called, that's the base implementation for all of the methods that, for all of the initialization methods that we have, I'm going to say shared game state equals Singleton and called the shared game state instance method. Save that. Okay, and it's built okay, so no obvious errors have been introduced yet. So that now means that, again, we've gone and grabbed an instance of it. Now this is the second time, probably, if this was the first time we called image in our game after we'd initialized this shared game state already. When we go through that shared game state instance method, it's going to have already allocated and initialized an instance of that class. So all it will do is it will skip that and pass back that instantiation. So we're accessing exactly the same instance of that particular class that was created inside our EAGL view. So you can see how we're going to now start sharing the information that's in there. So what I need to do is, inside the implementation, is go down to where we're rendering that particular, or we're actually doing the rendering, and you'll see here that my code at the moment is currently actually querying OpenGL and saying what is the currently bound texture, and then checking that against the name or the texture that is being used for this image, and if they're different, we bind that particular texture. That's not a good idea. Doing these get integer values inside OpenGL can actually be quite costly. The performance can be quite poor. So for that reason, we're going to change this code. We're going to replace it. So I'm going to get rid of all that we've got here. And what we need to do is we need to do an if statement. And we're going to check the texture that's associated with this image. And we're going to get the name, which is the texture name, which is an unsigned integer. And we're going to say if that's not equal to our shared game state, which remember we've created that when we initialized this particular image, and we're going to get the currently bound texture. So if the texture for this particular image is not the same as the currently bound texture, then there's two things we want to do. First of all, we want to update the shared game state object and actually set the currently bound texture to whatever the texture name is, like that. And then we actually want to do the gl bind texture command with a gl texture 2D and passing in the texture name. So we actually then bind that particular texture to the GL pipeline so that it will use it and save that. Okay, we'll do a quick build to make sure there's no obvious. That's good. So that's now how we're using it. We are checking the current texture for this image against the currently bound texture that is stored inside this Singleton class, and if they're different, it means we need to update the currently bound texture. So first of all, we set it in our Singleton class for other objects to be able to then query, and we then bind it inside our OpenGL. So I'm going to save that now, and what we'll do is we'll now move to the next implementation which we need to change, which is going to be our angle code font implementation. So again, we'll jump into the header. I'm going to do an import here like so, and it's going to be of the Singleton game state again, and I'm going to set up our variable, which is going to be our game state, change that name, shared game state, like so. Save that, drop it into the implementation. Now again, here where we do the initialization, which is up when we do init with font image named, I'm going to grab our instance so that we can then use it inside here. So we say shared game state equals Singleton game state shared single instance. Okay, so that's how we're grabbing it each time. We then want to go down and actually change the implementation of the render method so that again we are being good in that we're setting the texture correctly as is required. So I'm going to scroll down to the render, which is just here, and you'll see at the moment we're just blindly going and setting the texture each time, which we may not need to do. It could be that there's, and I don't know why there would be, but there could be multiple instances of this particular font, and the texture, it may be using the same texture, so we don't have to actually change the texture again. So we'll just be neat and tidy in this and actually use that. So what we'll do here is I'll keep that, and we'll say if, and we'll go into jump to the image being used for this particular font and get its texture, and from the texture we're going to get its name. And we're going to say if that's not equal to our shared game state currently bound texture, then we want to do the update. So we then say shared game state set, we want it to be image texture name is what we're setting it to, like so. We then, drop down to the bottom there, sorry about that. We then set the texture, and we then close off the if statement. So I'm going to save and build that to again just check I've not introduced anything silly. Nope, that's okay. So that's exactly the same kind of check we were doing for image now. Again, using this single instance of a class, so we're sharing that information again. And we'll now move to the last one, which is our tiled map one. And again, we're going to go through the same process we've done for the others. So I will import that Singleton. I will at the top here create our game state variable, which we're going to use, which is of type Singleton, and it's called shared game state, like so. I'm going to save that, and I'm going to then drop into the implementation side of things, just here. And if we go up to the top, we can see we've got the initialization routine again. So I shall put it in here. I shall set game state and say shared game state equals Singleton, and then do shared game state instance like this, and that's now set. And if we drop now down to our render routine, which we can find at the bottom, again here you'll just see that we're setting that. Now this is quite a, because the actual texture name is all the way inside a tile set, which is inside tiles, and it's quite a long-winded access. So what I'm doing is I'm actually grabbing the texture name once, and then we'll just reuse it. It makes it easier. Okay, so we're doing pretty much the same as we've done before. We're going to say if the texture name is not equal to our shared game state currently bound texture, like so, then we want to update it by setting the currently bound texture to texture name, like that. We then do our bind, and we then close off, and we save that build, and there are no errors luckily. So that's what we've done. We've created our Singleton class, we've initialized it, and hopefully you've seen how we've gone through and we've shared that particular information by just grabbing the same instance over and over again. For me, this is a brilliant pattern. It's something I've not sort of been able to get my head around for a while, is how do you get static classes, which is something I used to do in Java quite a lot, to sort of share info. This looks great. This is exactly how it looks to be done inside Objective-C. It seems to be working fine. So what we'll do though, just to finish off, is we will just save this and actually then run it to make sure that it is working properly. So let's hit run here and we'll have a look at the simulator and see if it's doing what we expect. And there we go. So it's not really changed anything on the screen, but it now means that we are accurately tracking the currently bound texture inside a specific object designed to do that. And over the next tutorials, we can extend that state object to store many, many more pieces of state information that different areas of the game may use. So I hope you found that useful. It was just a short tutorial to introduce that, because I'm going to be using it from now on, and I wanted you to see how that was done. So stay tuned. I'm going to hopefully get the particle emitter tutorial done over the weekend, and we can then get that up on the blog and you can have some fun with that. So thanks for watching, and I'll be back with you soon.